Let's consider the foundation for the clubhouse that we're working on. From the plan layout, we can see this is the foundation, the GB1 that we have worked on before. And if we look this from a perspective, we can see that it has, of course, depth, height, and width. So if we were going to estimate the cost of this foundation, we have seen before that we have cost data for assemblies. So the assembly includes the cost of the excavation, the cost of the formwork, the cost of the concrete, the cost of the reinforcement. It includes all those costs in one line item. So all we have to do is to estimate the linear dimension of this foundation in order to calculate the cost of the foundation. Now, suppose that you are the general contractor in charge of this job, and you want to review the quotation that a subcontractor is giving you to do the foundation. You would like to know the cost, of course, but you will also want to know what is the volume of concrete that you need for the foundation so you can compare your estimate with the quotation that you have received. You may also want to estimate the amount of rebar that you need to put in order to compare what you have received versus what you have estimated. So if we want to estimate the volume of concrete for this foundation, we know that it has a rectangular shape, right? So if we look close to this foundation here, we will see that it has a rectangular shape, right? It has a width of 18 inches and a height or depth of 24 inches, and then it runs continuously along these lines. So a, uh, a volume for this foundation can be estimated as the multiplication of the cross area, which is the length, the depth times the width times then the length of the foundation. So I'm going to go into Excel in under the calculations tab. I am going to create a line item here that I'm going to call calculations for GB1. So I'm going to write down the volume is equal to the width times the height times the length. So the width of the foundation I'm going to need the height, and I'm going to need the length in order to calculate the volume. So the width of the foundation is 18 inches. The height of the foundation is 24 inches. The length of the foundation is given by your takeoff from on-screen takeoff. So what I'm going to do is I am going to reference the cell that brings in the length of the foundation from on-screen takeoff. So I'm going to click equal. I'm going to go to my OST tab, which is where I paste the dimensions, and I'm going to choose quantity 1, which is linear feet for GB1. So now I have the length of the foundation, and the unit of measure here is feet. So in order to calculate the volume, I need to multiply the width times the height times the length. But we can see that these dimensions are not consistent. We have inches and then we have feet. So if we multiply the three numbers, we will get square inch per times feet. That's not what we want. So we may want to create another cell here that takes the width, divide that by 12, and now this is the dimension in feet. So I can copy those and paste them below, and now I have the dimensions of this GB1 in feet. So to calculate the volume, I will go equal the width in feet times the height in feet times the length in feet. So I will get the volume in cubic feet. So that's how I would calculate the volume for GB1. I have the width, the height, the length, and then I get the volume. So now it's a good time to learn a additional feature of on-screen takeoff that may help us to do this work a little bit easier. If we go to on-screen takeoff and we look at our condition for GB1, we double click on that condition and then the condition property comes up, and we see that grade beam GB1 is 18 inch wide by 24 inch high, and we have here the dimensions. So the thickness is 1 foot 6 inches. That is of course the 18 inches wide, and then the height, which is going to be 24 inches. So we can enter 24, or we know this is 2 feet, so we could enter 200. On-screen takeoff, as a reminder, he likes the software reads these numbers as the last 2 digits will be inches, and anything before that is going to be feet. So if you want to enter 2 feet, the way to enter this number in on-screen takeoff will be 200. That's 2 feet 0 inches. You can also enter 24, and that will give you the same result. So now think about this. We have in on-screen takeoff, we have entered the thickness and we enter the height. So because we are measuring the length, it should be able to calculate the volume for us, and it does. We have here the results. We have quantity 1, which is length measured in linear feet. But then we have a quantity 2. So we can click on this pull down menu and select volume. So when we select volume, we can select cubic feet, or we can select cubic yards. Let's leave it in cubic feet just for comparison. We click apply, we click OK, and now when we open a little bit wider this screen, we see that GB1 has now 1048 linear feet, 3252 cubic feet. When we look at our Excel file, we see that we have calculated 3252 cubic feet. So we trust the calculation from on-screen takeoff to be accurate. Previously, we also estimated the volume for our pile cast. So we had the volume is pi times the diameter squared times the height divided by 4. So given the diameter and the height, we estimated 31 feet high. So we estimated the volume of each one of these pile casts at 33.14 cubic feet, right? So if we enter a couple of lines here in Excel, I'm just going to select the rows and click insert. I can also include here the number of piles. These numbers, of course, come from on-screen takeoff. We have a count condition for the number of piles. So I'm going to select the number of piles here, each. And now I can estimate volume of concrete for the piles. And this is going to be the volume of each pile multiplied by the number of piles. And of course, this number is again in cubic feet. So now let's go back to on-screen takeoff and do the same trick that we did before. We select the cast piles. We have the width, which is 1 foot 2 inches. That is the 14 inches diameter of these pile casts. Then the height, we enter 31 feet. So this will be 31 feet 0 inches. The way that I would enter that in on-screen takeoff is 3100, meaning 31 feet 0 inches. When I click on the notes, I can see that on-screen takeoff has entered 31 feet. If you type in 31, that's going to be a mistake because it's going to consider 31 inches, which is 2 feet 7 inches. So now that I have the correct value for the height, I have the width, then I can select quantity 2, similarly to what I did before, select the volume in cubic feet, click apply, and now on-screen takeoff is going to calculate the volume for these piles automatically. So it says that we have 83 piles, and the total volume is 2,751 cubic feet. 2,750.57 is what Excel calculated, which is rounded up to 2,751. So we can see that the volume that we calculated using quantity 2 is also accurate for circular shapes, not only rectangular shapes. Now that we're in this topic, you can see that there is also a quantity 3. So one example of how quantity 3 can be used is for the foundations. If we need to calculate individual components, we need to figure out the area for this formwork. The area of this formwork is going to be the side area that is in contact with the concrete. So that would be the length of the foundation multiplied by the height of this foundation. These foundations are 24 inches high. So for every foot of foundation, you have 24 inches going height and then 1 foot across on each one of these two sides. So you will have 2 feet for every foot that you go in the direction of that foundation. So we could estimate using Excel the area for this formwork, but really we could use also the third quantity in on-screen takeoff. Just double click on your condition again, and then on quantity 3 use the pull down menu and look at the different options. We have length, which is the similar length that we had before. Then we have segment count. Segment count would be a count of how many segments I have counted or I have made to estimate the length of the foundation. In this case, that number may not be relevant, but in some other applications where you have length of items that are covering a length, then you may be able to, you may be interested in a segment count. Then we have surface area single side. This is the case. It's very helpful to estimate areas for walls. So you have just one side of the wall, you estimate that dimension, you're done. Surface area both sides is what we want here. We want both sides of that foundation to calculate the surface of contact from the formwork to the concrete. Then we have surface area top and bottom. This will be the bottom and the top of the excavation. Surface area single end or both ends, or then all sides, as would be the case for a duct, where you have a rectangular duct and you want to estimate the area on all 4 sides. So for this one, we care about surface area both sides, and then the result will be in square feet. So when I click apply, okay, now I have 3 numbers for GB1. The quantity 1, linear feet, this is the linear dimension. Quantity 2, cubic feet, this is the volume of the concrete that will be inside. And quantity 3, square feet, which gives me the area of contact between the concrete and the formwork. Now the only thing left to do is I could take this takeoff GB1 and import that information into Excel. Now I want to grab this information and bring it into Excel. So I will click on the rightmost cell of this takeoff and then drag the mouse all the way to the number of the condition release. This line will go blue. I right click on it, select copy, go to Excel into OST, and then for GB1 just paste the information over there, and you can see that now I have updated information for GB1. It has 2 feet height, it measures 1084 linear feet, it has 3,252 cubic feet, and then the unit 3, it's 4,336 square feet for formwork. This number um, can be verified with your calculations in Excel if you would like to take the time to multiply the length of the foundation times the height that you have on both sides of that foundation. Because the foundation is 2 feet high, you should have 2 feet on each side, so it's 4 times. Therefore, the area of contact should be 4 times the length. If we see in on-screen takeoff, actually the area of contact is 4 times the length. So that ensures you that the calculation has been done correctly.